What's good, guys? So today is Geometry 3.2, course Converse theorems and postulates. Alright, let's go. So the postulate of corresponding angle states that if, let's just say, angle 2 and 6 are the same, angle 2 is congruent to angle 6, then they are they are corresponding. Alright. Since angle 2 and 6 are the same angle, they are corresponding. That's the converse corresponding. And you don't know if they're parallel or not. The converse corresponding tells you if you see the angles on the same side and same corner, then they're corresponding, they're the same angle, then they're parallel. This is the same for, let me go here, 1 and 5, and another color, 3 and 7, and angle 4 and 8. If these are corresponding, they're the same angle, same corner, same side, they're corresponding. They're congruent, they're corresponding angles. That's the converse corresponding angle theorem. Alright, guys, the second one. So is all converse of I put it on text. Alright, so the next one is converse alternate interior angles. So on the last video we went over what a interior angle was. If you don't remember, alternate interior, this side. Interior is this side. So alternate interior tells you if these two angles are congruent or equal to each other, then they are parallel, as well as these two interior angles. Converse difficulty, so I had to erase the text for a second. So our next theorem is the converse alternate exterior. So this one states that the alternate exterior angles states that if these alternate exterior angles on the outside, right here, 1 and 8, and let me change the color, 2 and 7 are congruent, then they are parallel. So if 1 and 8 are congruent, 2 and 7 are congruent, then these two lines right here are parallel. You can deduct that they are parallel. I'll have the text back up in a second. So consecutive exterior angles. Converse of the consecutive exterior angles theorem. So if 1 and 7 equal to 180, m angle 1 plus m angle 7 equal 180, lines are parallel. This also applies to 2 and 8. Converse of the consecutive interior angles. This theorem states that if angles 3 and 5 are equal to 180, lines are parallel. These arrows I drew mean that the lines are parallel, that they're parallel to each other. So if you see that, that means the lines are parallel. You don't have to use these theorems. This also applies for angles 4 and 6. If these equal to 180, then these lines are parallel. Something I didn't explain was that the converse is exactly opposite to what the normal says. So converse, you could think of it as if Q, then P. But the normal is usually if P, then Q. Something I want to go over better is vertical angles. Vertical angles theorem states that if intersecting lines, then angles 1 and 2 will be the same. So let's just say here, m angle 1 is congruent to m angle 2. So you see here, they're equal. So let's just say here, 3 and 4. These are going to be congruent. That's the vertical angles theorem. Last thing, this is 3.2. So if this is line 1, line 2, line 3. So if line 1 is parallel to line 2 and line 3 is parallel to line 2, L1 parallel to line 2 and L2 parallel to L3, you could deduct that L1 is parallel to line 3. This is the transitive property. And yeah, that's it for today's video. Hope you guys learned something. If not, it's okay. And yeah, keep practicing.